So let's look now at a situation where you have repeated percentage change. So I'm going to go back to my bad drawings of t-shirts that no one would ever buy. And the problem with my t-shirt no one ever buy is that even when you put a discount on it, and the first discount is going to be 20%, people still don't want to buy it. And I can see why. Then they're offered another 20% off. So, what is the price of the t-shirt now? Well, we're going to use this example to deal with a really important and confusing issue. So, 20% is taken off the original price. Then when the t-shirt doesn't sell, 20% is taken off the price that is left. So, what is the cost of the t-shirt? Well, one answer people jump to quite quickly is that 40% has been taken off the cost. Now, let's have a look at what happens with the t-shirt. It starts at £20. When I take 20% off, I'm going to decrease the price by 20%. So I'm going to find 80% of the price. So I'm going to times by 0.8. And that takes me to £16. Now, that was the sale price, and then someone took 20% off the sale price. And this is where the wording becomes crucial. It's 20% off the sale price, not 20% off the original price. So, to find the new cost of the t-shirt, I take £16 and take 20% off that. Which takes me to £12.80. Now the question is this 40% off? Which was what was claimed earlier. Well, let's take £20 and take 40% off in one go. So a decrease of 40% will leave me with 60%, which is 0.6. And that comes out as £12. So what's happening here? I took 20% of 20 and 20% of 16, and on the other side I took 40% of 20. So this is my two-step calculation, and this is my attempt at a one-step calculation. Can you see why they've come out differently? Here is the reason why. Can you explain it yourself? 20% of 16 is not the same as 20% of 20. What that will mean is that this isn't the same as 40% of 20. In fact, 20% of 16 will be smaller. In fact, it is £3.20 compared to £4. So actually, the decreases are less. The key thing in the wording here was sale price. So you lost 20% off this price, and then you lost 20% off the sale price. So repeating the percentage doesn't actually do the same thing as you thought. Should we look at another example to try and help you understand this point? Because it is very crucial. Let's look at something that costs £40. And it's going to have 50% off, and then it's going to have 50% off the sale price. Now, if you're taking 50% off twice, the mistake we'd have made earlier would be to take 100% of the price away, which would mean that the object would cost nothing. Well, let's take 50% off. So let's half this. That makes it £20. If we take 50% off the sale price, it drops to £10. Whereas if we take 100% off, it drops to free. So, in theory, you can keep taking, let's say, 10% off something over and over again, and it won't run out. Why won't it run out? Well, you'll always have 90% of the previous amount left. It might get small, but it's not going to disappear. Let me use the calculator to show you this. So let's start with £40 and let's multiply by 0.9. So losing 10%, there it is. Now, if I times by 0.9 again, I get 32.4. So that's done twice. If I hit equals, it will do it again, because it's repeating this sum. So that's 3 times, and 4 times, and 5 times, 6, 7, 8, 9, 10. Why have I stopped at 10? Well, 10% 10 times might have been 100. But actually, 10% 10 times has not gotten rid of the whole number. And we can keep taking 10% off. Loads and loads and loads. You might notice now that each time I click the button, it's dropping by a very small amount. That's because 10% of a small number is a small amount. This is a repeated percentage change. And now we need to look at how we actually do one. So, the t-shirt in our example costs £20, and it was reduced by 20% twice. So the first reduction was timesing by 0.8. The second reduction was to take the answer to this sum and then times it by 0.8. Now writing that out isn't a problem, but is there a nicer way of doing it? Can we simplify the way we write this? Well, let's look at a similar case with bigger numbers to try and force the issue. Let's reduce it 6 times. So that's 20 times 0.8. Then the answer times 0.8. Then the answer times 0.8. 1, 2, 3, 4, 5, 6. So it's 20 multiplied by 0.8 to the power of 6. It's a decrease. You can see that because this number is below 1. It's applied 6 times because the power is 6. And this looks just like before. If the power was 1, you do it once, you just do 20 times 0.8. So here we have a method for doing repeated percentages. So let's look at another situation and try and apply this rule. A bank takes £1,000 of my money and it offers me 5% compound interest, which means at the end of every year they give me 5% interest on what's in the account. So that means 5%, then 5% of the new amount is added, and then so on. How much is in the account after 4 years? Well, I start with £1,000 and I work out the multiplier. 5% will be, if interest is an increase, so it's 105%. Count back 2 spaces, so it's 1.05. I'm going to have to do this 4 years in a row. So the power is 4. And there we have it. Let's look at a car now. A car depreciates by 15% each year. I spend £8,000 and keep it for 5 years. What is the value now? So it depreciates. And look at those first 2 letters. Do you think this goes up or down? Do you think it's an increase or a decrease? Well, you're right if you said decrease. I'm left with 85% each year. So it's 8,000 multiplied by 0.85 5 times. So, by now you're starting to feel quite confident on this, but there are some tricky situations, and I'm going to show you one of those now. A car loses 10% of its value each year. After how many years is 30% of its original value left? Okay, so we don't know the cost of the car, but we know we want 30% left. So, and every year it loses 10%, which is a decrease. So a decrease of 10% means we have 90% left, which is 0.9. Right, so here's what we do. Let's set the cost of the car up as 1, and let's times it by 0.9 once, and we get 0.9. Now we're looking for it to be 30%, which is 0.3. So we're going to have to do the decrease twice. That takes me to 0.81. And I'm going to have to keep doing the decrease until I get to a value of around 0.3. So there's my 0.729, and when I've got it say answer times that, if I hit equals, it'll do it again. So that's 4, that's 5, that's 6, that's 7. I'm not writing these down because I only need to get the key values. 8, 9, 10, 11, that's very close. I'm going to write that one down. I'm going to put 3 dots because I don't want all those decimal places. 12, 0.28. So, it's after 12 years. And if you remember back to the start of this video, 10% for 12 years would have been impossible with the misconception. You now need to practice this, and then we'll look at some reverse percentages.